In this quick review, we want to talk about the counting methods called permutations and combinations. And I'm just going to give a quick overview of what they are, and then we're going to not focus on the formulas for them, but I'm going to show you how to use your graphing calculator to compute them. All right, so what exactly are permutations and combinations? It's basically the number of ways to select R objects from N objects. And this is where R is less than or equal to N. And so basically, this is something like, hey, I have 10 t-shirts and I want to figure out the number of different ways I can select 6 of those 10. All right. So it's all R will always be less than N. The N objects are unique. Sticking with the t-shirt example, each of the 10 t-shirts are different. Once an object is selected, it cannot be selected again. For example, if I want to pack those t-shirts for a trip, I want 6 t-shirts. I'm going to be on a vacation, say for 6 days. I'm not going to pick the same t-shirt for all 6 days. So once it's selected, I don't select it again. And then the fourth option is where permutations and combinations differ. Okay. If the order of selection matters, this is a permutation. And we denote it this way. NPR, so subscript N, subscript R, so it's N pick R objects. Or if the order of selection does not matter, it is a combination. And we denote that as NCR, so N choose R objects. Okay, so basically all that's really important here is you got to ask yourself, does the order matter? Does the order not matter? And so I have one example of each of these. All right, so here's the first one. In how many ways can individuals in, let's say, a 10-person race finish first, second, and third? Okay, so we have 10 people, so that's my N. And how do I want them to finish? I want first, second, or third. So I want to select just the individuals that finished first, second, third. So I want to select 3 of them. And so now you have to ask yourself, this is a race. Okay. So does order matter in a race? Yeah, I want to finish first. I don't want to finish third. Yeah, so order matters. So when order matters, this is a permutation. So I have 10 people, and I want to pick the top 3 of them. So in your graphing calculator, you're going to notice there's this button called Math. And then you're going to see this option called PROB. And then if you look at options number 2 and 3, you see NPR and NCR. All right, so depending on your calculator, the easiest way to do this is you're going to take the first number, 10. Then you're going to press Math. You're going to go over to PROB. Then you're going to go to option number 2. And I have 10 pick 3. And it looks like, wow, there are 720 different ways that you could select the top 3 finishers in a 10-person race. Okay, now let's take a look at combinations. All right, so there are 16 full-time faculty in the math department at WCC. Okay, so that's going to be the total number of individuals, N. In how many different ways could 3 full-time faculty, so I want to select 3 of them, to serve in a textbook or on a textbook committee? Hmm. So you just have to ask yourself this. Does the order of selection matter here? Well, I'm going to select 3 people. If I'm selected first or third, am I still on the committee? Yeah. So the order of selection is not important here. So I have 16 faculty and I want to choose 3 of them to serve on the committee. All right, well, let's see. So again, remember, you're going to start with the first number, 16. I'm going to press math. I'm going to go over to PROB. I'm going to go down to option number 3. And it looks like there would be 560 different ways you could select those 3 faculty from the 16 where the order doesn't matter. Okay, as always, if you need additional help, please reach out to your instructor. And I hope this quick review helped.